do geometry. Yeah, baby. Okay. If I put a couple of lines on here, and I tell you that this angle is 2x plus 3 degrees, and I tell you this angle over here is 4x minus 1 degree, and I ask you, how large are those angles? Why could you set them equal?
Because they're the same angle.
Yeah. We know those are called what kind of angles when they're opposite angles? Opposite of intersecting line? Starts with a V. Those are vertical angles.
Yeah, I know that.
And so vertical angles are equal. And so then, yes, you can solve for x. That's no big deal. But I'm going to get x equals 2. Is that the answer?
No.
The question is, how big are the angles? Yeah, and it doesn't matter which one I put it in? No, because they're the same angle. So put in whichever one you like. So if I do 2 times 2 plus 3, they're supposed to be 7-degree angles. Obviously, I didn't draw them to scale. Okay, wanted to check about that one. The other one I wanted to check about here, well, let's see if I can do a decent job drawing this. A little bit of geometry we might occasionally need in trig. If I tell you that this angle is congruent to this one, this angle is congruent to the bottom one, and that obviously the two vertical angles are congruent, these are sides of 8 and 12. This one's 4, this one's x. I want to know how long is that side. What can you do? What kind of triangles are those? If all three angles are congruent. They are similar triangles. They are not congruent triangles because they're not exactly the same size, but they are similar, so that means I can set up what? You can set up a proportion because we know that the sides are proportional. Okay, so I'm hearing a 4 is to 8 as x is to 12. There's actually several different ways you can set that up and be correct. As long as you get the sides that correspond together. Definitely 6? How'd you get 6? If you cross multiply, 8x equals 48, and x does indeed equal 6. And they're both halves. Yes, there's a million ways you can get it. These two angles are the same? Oh, that should, sorry, no, sorry, I should have put 3. Sorry. No, you don't know that those are the equal angles. So that's the teeny tiny touch of geometry I'm throwing at you for right now. We will find use for alternate interior angles and parallel lines coming in a few days. But let's do real life trig. Okay, when you all first learned trig in geometry, you learned either the saying Oscar had a heap of apples, or you learned Sohcahtoa. Okay. So whoever taught you, whichever way they taught you, that's fine. That's if we're talking about whether our sides are opposite, adjacent, and hypotenuse. But we aren't looking at trig functions that way today. That's next class. We also look at trig functions in terms of a coordinate system. So if I put an angle on a coordinate system, if I'm talking coordinates, we don't represent our angles with ABC. We represent our angles with Greek letters.
Why?
And you may recall the most commonly used Greek letter for angles is the Greek letter theta. You can use other Greek letters, but theta is kind of the universal, hey everybody, this is an angle. I want to talk about what the 6 trig functions are in terms of the ratios of sides of a triangle. If I want to turn that into a triangle, where would I need to draw a third side? You always draw to the x-axis. You never, ever, 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 ever draw the triangle going over to the y. Never, ever do that. It will mess you up. It's always down to the x-axis. Okay. Since this side along the base is measuring how far over we are on the x, we call that side x. And this side that's going up and down is y. And this side that's moving around the circle,
That's your terminal thing.
if I actually made it into a circle, that would be the what of the circle?
Radius.
That would be the radius of the circle, but I don't want that in there. It's going to make a mess. So yes, that would be the radius of the circle. Away. So we call it R. Whoa, dude, I got a flag. Alright, so we have X, Y's, and R's. And it does not matter where I put that triangle. If I put that triangle down here, say I put it in the third quadrant, when I draw the triangle, I always draw to the x-axis, and I still have the side going horizontal is x, the side going up and down is y, and the hypotenuse is always r. It does not matter where you position the triangle. They're always in the same place. Okay. All the trig functions are ratios of sides. The Greeks way back when went, oh, okay, I want to talk about the ratio of one side over another, and they said, hey, I'm going to name it sine. Sine is the ratio side y over side r. They just defined, that's what sine is going to be. Cosine is x over r, and tangent was defined to be the ratio y over x. By the way, you will never, ever, ever write a trig function in this class without having an angle with it. Either you actually have to have an angle measurement in degrees or radians, or you have to have a variable there representing your angle. We will not write sine without an angle because then it's sin. Because if all you write is sin, that is the word sin. It is not sine until it's got an angle with it. So you will write angles with your trig functions.
What if we put a G in it?
Alright. The other three trig functions that we learned last year, in geometry you only learned these three, but we learned there were three others, and they pair up with these three. Okay, I'll give you a hint. Two things that start with S are never paired, two things that start with C are never paired. So yeah, secant goes with cosine. CSC is cosecant. And then cotangent, yes. Because notice you have sine and cosine, secant and cosecant, tangent and cotangent. Okay. Now, does anybody remember how you get these other three? Yes, they're the reciprocals. So cosecant is nothing more than sine turned upside down. It's r over y. Secant is the reciprocal of cosine, it's r over x, and tangent is, or cotangent, excuse me, is x over y. Okay. So, you will soon have those learned because we use them tons, but does anybody remember the same? For remembering these three, the first three?
That's not an xylophone.
Stupid.
Victor Roxton, xylophone, right?
Not up. There's no U.
Right.
Stick your rotten
Stick your rotten
face
face right on right through your.
right through your X. They never could come up with another X word that works. So stick your rotten, crazy xylophone right through your X. It's worked for years. People remember their trig functions. Because I'll have them sitting there going, cosine, crazy xylophone, right, X over R. So that will, it seems to help you. I've never gotten a really great one for this side, but we don't usually need one for this side because you just know they're the reciprocals. You just know you need to flip them. So we haven't really had a whole lot of use for having one on the right hand side. So there's your memory device if needed. Okay. The other key thing you have to know that we learned last year, which was another saying, the trig functions change from positive to negative depending on which quadrant they're in. if you'll notice here in the first quadrant, X, Y, and R would all be positive values. But this one I drew in the third quadrant, X is going left, so wouldn't X be a negative number?
Isn't this the same thing I have on the
And Y would be a negative number?
It's the same thing.
Close. It's related.
Let me see.
It actually has some, it's,
Get nerdy with it.
R is a radius. Is a radius ever negative? No, R is never negative. R is never negative. So consequently, for example, sine in the first quadrant, Y over R, they're both positive, so you're going to get sine as a positive value. But sine, when you do Y over R in the third quadrant, negative Y over R, you're going to get a negative number. So sine is negative in the third quadrant. Okay, does anybody remember the saying for how to remember the quadrants of where they're positive and negative?
No.
I'll give you a hint. They're all positive in the first quadrant.
Oh,
That's not going to show up very good.
I know this one. Oh,
Yes. Yes, it was all-star trig class. That's what you're going to be, is an all-star trig class. Okay, so the S, the T, and the C stand for sine, cosine, and tangent, your primary three trig functions. So the S tells you sine, the T tells you tangent, and the C tells you cosine. Okay, if it's listed there, it's positive in that quadrant. So that's all. They're all positive in the first quadrant. They all have two positive quadrants and two negative quadrants.
So the top two are positive, right?
Okay, so sine is positive in first and second. Tangent is positive in first and third. Cosine is positive in first and fourth. So these are where they are positive. Okay. What else would be positive in the second quadrant with sine? Cosecant, because it's the reciprocal. So sine and cosecant stay paired together. They are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant, and cosine and secant.
You have a message, Miss Meyer.
That means I got an email message. I forgot to turn my phone off. No big deal. Okay, so we know which quadrants we're in. Okay. Thank you. Okay. I am actually, we need this out here. Pause that a second, because we need to wait while I write. Okay, they're going to ask you, this is why your assignment looks really quite long, but doesn't have much work. They're going to give you some information and say, tell me what quadrant we're in. So if I say to you, sine's greater than 0, and tangent of the same angle is less than 0, what does it mean to be greater? Guys, I have 7 minutes or 5 minutes. Because sine's greater than 0 means it's positive, doesn't it?
Yeah.
And tangent's less than 0 means it's negative, so I'm asking you, what quadrant are you in if sine is positive and tangent is negative? Okay, no, where they're written, that's when they're positive. So, sine can only be positive in first and second. It couldn't be third and fourth. Where's tangent negative? It can't be first, so yeah, it'd have to be second quadrant. Okay, what if I asked you what quadrant are you in if secant's less than 0 and cosecant of the same angle is less than 0? Where are they both negative? I have several votes for 3. I will buy 3. Okay. For it to be negative, secant's positive in first and fourth, so it has to be one of the two on the left side. And it can't be 2, because that's where cosecant's positive, so you're down to 3. So you have several problems where you just have to name the quadrant. Is that going to blow your mind? Yes. Okay. Yeah. Okay. Okay, I'm going to shorten the instructions here a little bit. Some of your problems are going to give you some information. In this case, they're going to tell you the angle goes through the coordinates Negative 2 square root of 3, comma 5. I want you to find secant of that angle. Okay, this is where you're going to draw a picture, 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 draw a picture. I'll count them wrong, come test time, quiz time, or any other time if you don't draw me a picture. I don't care if you can try to reason it out in your head, you will draw me a picture, because it's going to matter later on. Okay, so if I'm going to you to draw a picture, what quadrant are you in if you have those coordinates?
You're going to be negative.
You went left and up, didn't you? Okay, you don't have to draw a scale, just slap an angle out in the second quadrant. Do a triangle. Okay, since we know we went over negative 2 square root of 3, don't we know that bottom side is negative 2 square root of 3? Yeah. Oh, and we know up is 5. Okay, to get secant, which two sides do I have to know?
R and X.
I have to know r over x. So, do I know side r and side x in that picture?
No.
I need r, which means, oh no, I'm going to have to do the Pythagorean Theorem. Oh my. Oh, wow. The hardest math you have today is the Pythagorean Theorem. Okay. Now, my question is, what do you get when you square 2 square root of 3? 4. When you square the square root, you get 3, so you get 12. Which means that adds up to 37. Which means r is the somewhat, a little over 6, but we're going to go with square root of 37. We don't go to decimals. Okay, so now, name the answer. You wanted r over x. So, r is always the hypotenuse, and over x, which is the 3. Okay, I wish I could say don't rationalize it, but these books rationalize the answers. So you have to get rid of the square root of 3 by multiplying by square root of 3. So that's something that needs to go from math, but it hasn't gone yet. 37 times 3, 21, 111? Did I multiply that right? Yeah. And what's the bottom?
Negative 2.
3 times 3, square root of 3 times square root of 3 makes 3. And 3 times 2 is 6. Okay, on your assignment, you're going to see a problem, it'll say like problem 17, and it'll say sign after it. The instructions in the book tell you to find all 6 trig functions. I'm telling you just find sign. If you can find one, you don't need to find all 6. It's the same process. So you don't have to find all 6 when it says to do that.
Wait, when is it marked?
You find whichever ones. I wrote it after the problem number. It tells you which ones to find. So they're going to leave the answer just like that. A lovely square root of 111 over 6. So 111 does not break down. Okay. Okay. This is the one last problem I really, really, really need to do. That's negative 3/7. Okay, you work it the same way we just worked this one. It's just a little trickier to draw the picture. And I want to see if you can draw the picture real fast. The big question is, this one you knew where to draw it because you could tell the coordinates, what quadrant you're in. How do I figure out on this one what quadrant I'm in?
Third quadrant.
Why? Cotangents greater than 0 means it's positive. Cosine's negative. So where's cotangent positive and cosine negative? Cotangent's positive in the third, cosine would be negative. So I'll buy Colin's third. Now, how do you figure out sine?
Well, what is cos? Cos is x over r.
Yes.
So that's negative
Yes.
3 over.
Go to your trig function. Cosine is x over r. So therefore you know x is 3, r is 7, and you have to look at the picture to know which one gets the negative. Yeah. Then you can do Pythagorean Theorem and answer the question. Now you got to draw the picture. Draw the picture, draw the picture, draw the picture, draw the picture, draw the picture. When you get to the problems that say possible and impossible, I'll text you. You can't do those because I didn't get to show you the chart. They'll ask you for possibles and impossibles, and you won't be able to do that because I didn't get to draw the chart for you. I need 2 minutes. Okay. I don't do all anymore. I don't do none like what, 3 weeks since I've seen almost?
You can't see those towels.